We've seen many different classes of languages in this course and many different ways of defining them, using grammars, using automata. So it's time for a summary. These classes of languages and the relation between the languages is known as Chomsky hierarchy. This is the Chomsky hierarchy. We have different classes of languages. They correspond to different types of automata, and they can be defined via different variants of grammars. The smallest class of languages that we've discussed are the regular languages. They can be defined via deterministic finite automata and non-deterministic finite automata. Both versions of automata are equally expressive. The regular languages can also be defined via regular grammars, in particular via right linear grammars. We've seen one more way of defining regular languages in this course, which is not mentioned in this slide, and that's the well-known regular expressions. The next bigger classes of languages are the deterministic context-free and the context-free languages. The context-free languages can be defined via non-deterministic push-down automata and equivalently expressive via context-free grammars. There's a subclass of the context-free languages that's strictly in between the regular languages and the context-free ones. That's the deterministic context-free languages. They can be defined via deterministic push-down automata. The next bigger classes are deterministic context-sensitive and the context-sensitive languages. The context-sensitive languages can be defined via linear-bounded automata. So recall that this is non-deterministic Turing machines that are not allowed to leave the bounds of the input word. And equivalently expressive are context-sensitive grammars. These are grammars where the right-hand side cannot be shorter than the left-hand side. We have, as a subclass of the context-sensitive languages, the deterministic context-sensitive languages, which are defined via deterministic linear-bounded automata, and actually it's not known whether this is a strict subclass. So it's not known whether the deterministic context-sensitive languages are really a strict subclass of the context-sensitive languages. It's still an open problem whether deterministic linear-bounded automata are equally expressive as linear-bounded automata. And the biggest classes of languages that we have discussed, in some sense as complex as it can get, are the recursively enumerable languages and the recursive languages. The recursively enumerable languages are defined via deterministic Turing machines. These Turing machines, they accept a word if they reach a final state. They reject a word if either they reach a non-accepting halting state or if they compute forever. We get the subclass of recursive languages if we restrict to those Turing machines that terminate for every input word, so that no matter what input word we are giving them, always reach a halting state. So in some sense, these Turing machines are always required to answer yes or no for every input, whereas the general Turing machines that give rise to the recursively enumerable languages, they answer yes, but possibly they compute forever and they never answer no. The recursively enumerable languages can equivalently be defined by unrestricted grammars. So there's no condition at all on the shape of the rules except that the left-hand side is non-empty. Noam Chomsky, so who gave the name to the Chomsky hierarchy, is really a world-famous language expert as well as philosopher and political activist.